Welcome to this tutorial on logistic regression. In today's video, we'll delve into building a logistic regression model from scratch and evaluating it. Whether you're a beginner or looking to brush up on your skills, this tutorial is for you. Before we jump into the code, let's start with some key concepts. Logistic regression is a statistical model that predicts the probability of a categorical dependent variable. In simpler terms, it helps us classify data points into two or more categories based on independent variables. For our example, we will use the famous iris dataset, which will help us predict species of flowers based on sepal and petal dimensions. First, let's go ahead and set up our environment. We'll need a few Python libraries, NumPy for numerical operations, pandas for data manipulation, and scikit-learn for building our model. Now, let's import these libraries in our code. Next, we will load the iris dataset. You can easily load this dataset from the Seaborn library. We'll also take a peek at the data to understand its structure. Now that we have our dataset loaded, let's examine its shape and the unique classes in our target variable. This will help us understand how many categories we need to predict. Next, we need to pre-process our data. In logistic regression, we need to convert our categorical target variable into numerical values. So, let's encode the species column. We also need to split our data into features and labels. The features will be our sepal and petal dimensions, while the labels will be the encoded species. Now, we will split our dataset into training and testing sets. This is important to evaluate the performance of our model on unseen data. It's often a good idea to standardize our features to ensure that they are on the same scale. This is especially important for logistic regression models. Let's scale our features using standard scaler. It's time to create our logistic regression model. We'll instantiate the logistic regression class and fit it to our training data. Next, we want to use our train model to make predictions on our test dataset. With our predictions ready, let's evaluate the performance of the model. We'll calculate confusion matrix and display the accuracy score. Now, let's delve deeper into our model's performance using the classification report, which includes precision, recall, and F1 score metrics. To visualize the confusion matrix, we can use a heat map. This will allow us to better understand how well our model is performing across different classes. As we can see from the confusion matrix and the classification report, our logistic regression model has performed decently. However, we can further improve it through hyperparameter tuning or trying different features. In conclusion, we have successfully built and evaluated a logistic regression model step by step using Python. We covered data loading, pre-processing, model training, prediction, and evaluation. Thank you for watching. If you found this video helpful, please give it a thumbs up, share it with your friends, and subscribe for more tutorials on data science and machine learning. If you have any questions or topics you'd like me to cover in future videos, please leave a comment below. See you next time.